I'm Mr. Laidan, and today we are going to have a final series of pharmaceutical calculations on the rate of flow of intravenous fluids, or rate of flow calculations. We need to know the secret behind intravenous fluids and how to go about them. We need to know the magic behind the flow of intravenous fluids. What determines exactly the rate of flow? What do we consider? The criticality of the patient will tell us whether we are going to run this IV fluid so fast, an average speed, or so slow. But how do we calculate this? How do we monitor the number of drops per minute? Let's have this equation here, which is a very interesting equation. So, infusion rate, the infusion rate, remember that rate means something over time. So infusion rate is calculated in terms of drops per minute. So drops per minute, this is the rate. And in order to calculate this, you need to have the certain volume of fluid which you need to administer to the patient. So we need to have the volume in terms of mils. Now, if you have your infusion, there is an infusion set just after the infusion. We know that there is a certain volume which goes through the infusion set or the giving set. So we need to multiply this volume by the volume of the whole fluid. So if we have the volume to be administered, then there is a certain volume passing through the administration set. Then this volume passes as drops per mil. So multiply by the infusion set, and this infusion set delivers volume in terms of drops per mil. Then you need to know for how long do you need to administer this intravenous infusion. Maybe that is dextrose infusion, normal saline infusion, lactated lingers, and whatever. So you need to know the time in terms of minutes. Having this, you shall have the rate of flow. So the flow, IV flow rate in terms of drops per minute is equivalent to volume in terms of mil, volume to be administered to the patient, times infusion set in terms of drops per mil, divided by time in minutes. But sometimes you may be calculating the infusion rate in mils per hour. Infusion rate in mils per hour. Then you need to have the amount of solution in mils, divided by the number of hours which you need to administer the fluid to the patient. Having known that, let's dig into some examples. A medication order calls for 100 mils of dextrose 5 in water to be administered over an 8-hour period using an IV administration set that delivers 10 drops per mil. How many drops per minute should be delivered to the patient? So when we counter words like how many drops per minute, that means you are looking for the rate of flow. So let's write the data here. So the medication order calls for what? For dextrose 5 in water. How much? This was so the volume of fluid. The volume of fluid is 100 mils. And this is dextrose 5 in water. This has to be administered over, so time, it was 8 hours. So, but it should be in minutes. Convert this to minutes. This is 480 minutes. Using an IV administration set, so the infusion set, the giving set to be used, it delivers 10 drops per mil. Delivers 10 drops per mil. So how many drops per minute? So what is needed is drops per minute, meaning rate of flow. should be delivered to the patient. So to know the flow rate, I said the flow rate in terms of drops per minute, you need to have the volume to be administered to the patient in terms of mils, times the drip set, volume going through the drip set in terms of drops per mil, then you divide by time in terms of minutes. So having known that, what is the volume here? The volume is 100 mils. Then drops, the drip set delivers 10 drops per mil, and time is 480 minutes. So drops per minute, this is 100 times 10 divided by 480, that is 2.083. 2.083 drops per minute. So practically we have no 2-point drops. So these are approximately equal to 3 drops per minute. Practically, as you are going to set this infusion, you are going to set it in such a way that the drip set, the giving set, will be dropping 3 drops per each minute. When 3 drops are dropped per each minute, this means after 480 minutes, the all 100 mils of infusion shall have been finished. Let's look at another example. Calculate the IV flow rate for 1,200 mils of normal saline to be infused in 6 hours. The infusion set is calibrated for a drop factor of 15 GTT per mil. GTT means drops per mil. So we are going to infuse 1,200 mils. These belong to normal saline, and time is 6 hours, equivalent to 360 minutes. Infusion set delivers 15 drops per mil. What is needed is the rate of flow. Okay, the rate of flow. How do we get the rate of flow in terms of drops per minute? We need to have the volume. This is 1,200 mils times the drip set. This is 15 drops per mil. Then time is 360 minutes. This will give us 1,200 times. This will give us 50 drops per minute. If these are 50 drops per minute, this means that we are going to set this drip set to deliver 50 drops each minute. If 50 drops are delivered in each minute, that means after 6 hours, 1,200 mils shall be finished and fully delivered to the patient. Let's go to the other concept of intravenous admixture, and this will be our last part.